I want to thank. That's perfect. That's perfect. I want to thank everybody that's here right now. My name is John. I often online go as JP, so if you see me in the Discord, that's who it is. And today I'm going to be walking you guys through kind of a primer on procedural generation. So first, we'll go through a little bit about me. Obviously, my name is John. I am a post-bac pre-med student here at Columbia. I spent 8 years in the Army before that, where I kind of picked up game development alongside some of my friends. I live here in New York City with my girlfriend Joan, who's here in the audience, and our snake Kaiba. You can see a picture of her on the screen behind me, and the share that you guys are seeing. Okay, so let's get into the talk here. So first and foremost, what is procedural generation? I have a textbook definition there on the slide that you guys can take a look at. However, I like to define it as putting together tools in a sandbox, right? You generate the rules to the sandbox, and then allowing the computer to create a world or a subsystem inside of that sandbox. So as the developer, we get to place constraints and watch what the computer makes for us. I have an example here to kind of illustrate that. On one side, we have Fallout New Vegas versus Minecraft. Fallout New Vegas is one of my personal favorite games. However, it's a completely hand-painted world. The developers went through and created particular characters at particular places. They have well fleshed out backstories, and they're there for a reason. And every time you boot up Fallout New Vegas, you're going to get the same map. Whereas Minecraft, it's familiar every time we play the game, but it's an entirely new experience. That's the radiator, by the way. But the experience itself is different every single time. You might see something new that you never saw before, but it's always familiar. The rules of Minecraft never change. So this begs the question, why procedural generation? And the first thought is because we're creatively bankrupt, right? As programmers, we're not really good at coming up with stories. That's just a joke, but realistically, there are a few really good pros to using Proc-Gen. It allows the possibility to make extreme scale with small development input. So you can have a computer generate tons of content for you as long as you're really strict and good about putting together rules. And because the game is familiar every time, but different in aspects, you have infinite replayability, where you can get really good at understanding the game, but every time you'll be confronted with new challenges. I think it's a unique thing that Proc-Gen provides. And then finally, this is a selfish take, but as a developer, when you're developing a video game, you don't always get the opportunity to play it as a player would experience it. And so Proc-Gen allows you to be surprised by your own game. And you're able to experience the game as you intended a player to experience it. So we talked about kind of the basics here, and we can't talk about Proc-Gen without talking about roguelikes. Has anybody here heard about roguelikes before? We have people here in the audience, right? We want to talk about where does that name come from? Not many people know because it's been such a long time. So we'll talk about history here a little bit of the roguelike. Starting in 1980, these two guys, Michael Toy and Glenn Wickman, for Unix-based systems created a freeware application called Rogue, which kind of it didn't start it, but it popularized procedurally generated content, run-based gameplay, and permadeath, right? A concept that we kind of take for granted and is a little bit arcadey, but they brought it into home computing at the time. So while Rogue didn't kind of start the generation, it really is the first touch point that we think about, and they started or popularized the idea. And we'll see as we go forward the DNA of Rogue in everything else moving forward. Moving on, I want to talk about Elite. You can see on the timeline slide I made here. Oh no! I think someone joined the meeting early. so we lost out on some time here. That's okay. I think we might be able to fix this one way or another. That we might have to send a new link out, but I'll keep going for now, regardless. In 1984, we have Elite. Elite is an example of scale. So this is a couple developers who created a fully realized 3D world in 1984 with 8 separate galaxies, each housing 256 individual systems. A fully 3D realized world at that time was unheard of, but having one with unique systems where each planet has their own backstory and information about them is insane. And a piece of, lore here is that it was 22 kilobytes, the entire game program. That's smaller than a JPEG. Everything's bloated these days. We can't appreciate that kind of stuff. I just wanted to bring it up. Then in 2002, we can't talk about Proc-Gen without bringing up Dwarf Fortress. Dwarf Fortress was created by 2 brothers in Washington State, where my lovely girlfriend Joan is from and where we came from, so to speak. But Dwarf Fortress is a procedural generation that spans, it's more ambitious than anything else we've really seen. Before you even get into the game, they simulate millennia of history, of civilizations, wars, economics, land erosion patterns, to bring you up to speed in the world, and then they allow you to play in that world. So it's actually more like a simulation and a piece of software than it is a game, but it's incredibly complex. 2008, starting in the 2000s after the Xbox arcade explosion, we have Splunky, created by Derek Yu. Kind of started to revolutionize what it means to be a roguelike, bringing us out of the ASCII graphics and simple or rather complex systems hidden behind characters on a screen, and brought it to a little bit more palatable place where it plays more like an arcade game. And again, developed by one person. We look at these things, and the procedural generation side is you can run Splunky all day, you'll have a new run every time. I included Minecraft on there just for timeline's sake, so we can all kind of understand where this is all happening. For those of us that were playing video games when Minecraft was in alpha. 2016, we get to The Binding of Isaac by Edmund Macmillan. And this is where we start to see the roguelite take off. Originally, it was roguelikes. They're very hardcore, unforgiving. The idea of a roguelite allows you to kind of progressively upgrade in between runs. So there's always forward progress outside of the actual game happening. A little bit softer representation of the roguelike, which is generally an unforgiving medium. I included a picture of Hades up here, kind of to show the future of where we're going, and kind of how far we've come. Hades itself is extremely popular. It's probably the face of roguelikes right now. I realize there's a sequel out now, but just want to bring this up. $160 million is the revenue that's estimated for Hades. And if we look back at Minecraft, it's somewhere estimated between $10 and $12 billion industry, which was originally made by one person, right? And this is a roguelike piece of software using procedural generation. So those guys back in 1980, they were onto something. So the question becomes, now that we understand our history, how do we do this? How do we create these systems and watch it go? That's what we're going to talk about. I want to remind you guys that you can place biases and edit some of these algorithms that we're going to talk about to suit your use case. However, I'm going to talk about this topic through a lens of 2D map generation. It's just the easiest way to go about it. It makes the most sense. But reminder that you can apply these to branching storylines or character generation. It's all just math at the end of the day. So bear with me for those of us that aren't math people. We're going to get through some cool algorithms here. The first one I want to talk about is a drunken walk, sometimes in statistics referred to as a random walk. And the idea is you pick a random point on a map and you start carving directions one at a time, right, in one of the 4 cardinal directions for a predetermined number of steps. And then you carve that out. So if you look at the GIF, not the hammered guy that's falling down, but the map that I have there, you can kind of see this at work. Each iteration is a full random walk, and we see it carve out a unique pattern here for us that, if you have some imagination, looks a lot like a cavern. So it's not perfect. The drunken walk is really useful, but it's not quite perfect, because sometimes it's just a little too random, and you can end up with either a really nice, cool, windy cavern or a big donut. And so we move on to our next algorithm, noise. Perlin Noise specifically, which is, don't stare too long at the noise texture, it might give you a headache, but it's a continuous grayscale. And when I say continuous, I mean that in mathematics sense, like a function is continuous, of values between 0 and 1, right, between white and black. And so if we look at our little Perlin Noise demonstration on your left, and we compare that to our elevation map on the right, we can start to see some similarities there. If we say that our black on our Perlin Noise map there is high elevation and our white is our low elevation, we can really start to see where this is used. It says I still have 20 minutes. I think we should be fine. And so I can't point to it. You guys can see where my pointer is at on the Zoom call. Okay, you can see it. Okay. You guys can see that too. That's perfect. This would be our high elevation spaces, right? Remember, it's just an oscillating scale between 0 and 1. So programmatically, we assign those numbers to elevations and then place them into the world. And we create really cool, unique, almost continent-looking structures this way. If any of you guys are keen or privy to it already, this is what Minecraft does. That's not really a good con. I said it creates a noticeable noise texture. Most people never notice that. That's really just developers might see it and want to hide it a little bit better, but I thought it was something that could be pointed out. Moving on to our next algorithm here, Cellular Automata. Based on a mathematical game called Conway's Game of Life. Any of our programmers or math people might be familiar there, but it's a generative game, and we use it in game development to simulate organic appearing features. Because what Cellular Automata does is it takes a certain starting situation and it checks all of the neighbors of each tile across the map to see if its neighbors are alive or dead. There's a certain living threshold of alive neighbors and a certain dying threshold of alive neighbors, just like bacteria grows in a petri dish. So this fundamentally operates the same way. And you can get yourself some really nice natural looking features and organic appearances. A great use case right now is actually being used by my mentees in the incubator. They're using Cellular Automata to generate trees in a forest. And this is like a classic use of CA. The best part about it is, using it for organics. It's also the way that bacteria or human beings proliferate. So it's kind of the way that humans also spread influence. So you can use it in a number of ways. Okay. Thank you for bearing with me through the heavy math parts. This is a little bit simpler, right? We're going to talk about rooms and corridors, which is really just that. I have the example of Rogue over there on the left side. And then this example that you guys are seeing on the slideshow, it's not my algorithm, it's not my GIF, but it illustrates the point well. We make random rooms. We have random rooms of random sizes. We make sure they don't touch, and then we connect them via corridors. And this creates a human approach, right? This is how humans build things. They separate, and then they create linear pathways between everything. what I was saying was the GIF here isn't mine. It's a lot more complex than what we're talking about. The implementation we're talking about is creating a series of rooms with no islands. So there's no rooms off on their own. Okay, we talked about a lot of algorithms. I did it kind of quick because there was a lot of pressure from the Zoom gods, but we're going to move on to the best part, is mixing and layering these algorithms for a more unique system, right? I included a picture here. This is Minecraft. This is the one that everybody knows. And if you look, every algorithm I just talked about is actually used in this photo of Minecraft. And I think it's pretty easy to pick them out. I'll give a second for people to take a look. The one that's hardest to find is where a Drunken Walk is used, but maybe some people will be privy to it. You guys see it? Yeah, the Drunken Walk algorithm. Not the layers of dirt, that's noise, right? If we look at a noise map, it looks exactly like the noise map does.
Is it something that's like very obvious?
It's obvious to me, but it's actually the clouds. So if you look at the clouds are drunken walks because they create abnormal random structures like that, right? Of oscillating left and rights. But I'll use the pointer here on the screen. We see our rooms and corridors right here in our Minecraft village, which is beyond my time of playing this game, but it's here. We see a noise map for the greater elevation changes. There's water beneath a certain elevation, right? The world works this way too. And then we have trees, which is a CA framework. So I had an experiment planned for us being in person. We can try and do something. There's only 3 of us, or there's 4 of us in the room. Are you guys down to do a little like walking experiment? Okay, so you guys might want to maximize like my screen here because I'm gonna turn the thing around. You guys okay with being on the meeting? Okay, because I'm gonna use my laptop camera to walk us through this experiment. Hopefully that we don't fail. Okay, hopefully this works. Almost. Okay, I got everybody. All right. So, you guys at home, you guys can think about it if you want to. Unfortunately, we can't include you because you're not here. But what we're going to do is we're going to generate a dungeon together right now. I am an adventurer on a dungeon. Can I get a volunteer from you guys? Who wants to be the starting room? Okay. My lovely assistant, Joan, is going to be the starting room. She's going to come up here. You can stand right here. Now, everybody in the room, I want you to start thinking about what is in your room, right? Don't tell anybody. There's not that many of us here, but start thinking about what is in your room. And in those 5 seconds that we take, so to speak, I'm going to do a countdown. And on that countdown, the 3 of you guys are each going to point at somebody else, right? That's all it is.
I can't pick you.
You can't pick me. Yeah, you can't point at me. One of the 3 rooms has to point at each other. So 1, 2, 3. Okay, look at this. So if you don't see, they're all pointing at each other. So we've already determined that Joan is the starting room. I'm the adventurer. I'm entering the dungeon, and I'm in Joan's room now. So what's in your room? Keys. All right. So I walk into the first room. I have some keys on me. And because these guys pointed at each other, I actually have a decision to make now, because you pointed at her as well, right? So I can go left or I could go right. Which direction should I go? Okay. I think I'm going to go left, right? I'll go left first. So now I go to the left. Now I'm in Lizzie's room. Lizzie, what's in your room? Treasure. Oh, this is a great day. I'm just getting rich. All right, so I take my treasure, and now I'm back in the entrance. I see the exit, but I've only found good things so far. So I think I'm going to gamble, and I'm going to go down this pathway to Sonali's room. So I take my steps down here. Sonali, what's in your room?
It's a desk and chair.
It's a desk and chair. All right, I've got some furniture for my house. Or I can study in a dungeon. So I take that with me and I leave the dungeon successfully. Thank you guys. You can sit down. So it's a limited example, but I think it illustrates the point that I'm trying to make here is that in just randomizing and bringing random elements into a map, a story evolved. And you can already tell the story. I told it as I was walking through the rooms. I walk into a dungeon, I found a set of keys. Where the hell do those keys go to? I don't know. There's some free loot down here. I got a whole bunch of money, but I don't know what to do with it. You know, it's just an example. If we have a lot more people, it gets a lot more fun and can get crazy. But I appreciate you bearing with us through the metaphor regardless. Okay, this would have been the group experiment slide. Okay, to wrap up, because I've already overdone it on the Zoom once, so we'll finish up here. I just want to talk about the future of procedural generation in some of these technologies. I know in the game dev space, AI generally kind of gets a bad rap. People look down upon it. I am in line with those sentiments. However, I want to provide a potential for an upside or a more positive outlook on new technology. I think that generative AI can play a role in the future of procedural generation, not in defining the systems, because I think that's wrong, not in creating the constraints of the world, but I think being a personalized builder in your sandbox that you create to tailor a one-to-one story for the player, right? So an adaptive storytelling method I think could be a great use case for generative AI. And I think that's something that we can think about. That's pretty much what I have to say today. I wanted to thank real quick Sonali, Lizzie, Yuki, and the rest of the game dev committee for putting together these talks and all of the incubator really. They make this machine run, and I think that's really cool. I left my contact info on the slide. That's my Discord username. It's the easiest way to get in touch with me. I also left a link to my portfolio site, so if you want to check that out, go ahead. You can get in touch with me there. And thank you, everybody, for coming on the Zoom. I really appreciate it. This was way more of a turnout than I thought we'd have. So thank you. I'm going to stick around for questions, too. So if anybody does have questions, I see we have stuff in the chat. Oh, it's Rob saying I love Minecraft. That's a personal friend of mine, and that's I expected that. But I'll stick around for questions. If anybody has anything they want to ask, fire away.